Hello everybody, my name is Muhammad Danish bin Muhammad Zaidi. For review paper presentation, I will present about the topic of geodynamic mechanism and classification of basin in the Earth system. In the 1940 to the 1950s, basin classification was guided primarily by the geosynchron and platform theory, while in the 1960s, basin classification has been focused on the plate tectonic theory. Geodynamic environment can be divided into three categories, which is compressional, extensional, and shearing. While in the research article, basin they had divided into five categories, which is extensional, transtensional, compressional, foreland, and cratonic basin. Other than that, I will discuss more about the basin and its formation and evolution, geodynamic mechanism of basin formation and evolution, and then last but not least is new geodynamic basin types. When we talk about sedimentary basin means we can refer it to a certain tectonic subsidence area on the Earth's surface that had been filled by sedimentary material and water loading. And basin formation mechanism and type have a certain reliability that related with the Wilson cycle. When we talk about the Wilson cycle, it is it tell more detail about how sedimentary basin is formed. As we can see from the Wilson cycle, the basin dynamics of the first half of a Wilson cycle is dominated by the extension, whereas the rest are controlled mainly by extrusion and collision. Shearing, including the transtension and transpression, can coexist in any part of the cycle. Any conceptualization of a basin must consider three elements, which are material, space, and time. Extensional basins are well developed globally in the Mesozoic and Cenozoic. The Mesozoic-Cenozoic flexural basins are mainly developed and distributed in West China, Middle East, Russia, America, Africa, and some other regions. As we know, the Cratonic Basin is widely distributed all over the world and developed mainly in the early Paleozoic and early Mesozoic. The formation and evolution of basin generally experience many geological actions such as thermodynamics, gravity, stress, and dynamic processes. With the extension of lithospheric plate, a passive extensional basin may form, which causing the mechanical thinning of the lithosphere. Based on the initiation and development of the fault system, the magma may inject upward along the fault system and even erupt to the surface, which can cause a passive basin to transform into an active extensional basin. Stratosphere and upper mantle would be partly molten, along with the ongoing crust-mantle interaction. It means a new mafic magma intrude into the lower crust to form a diaparism and underplating. With the propagation of magma channel, and fault system, as well as the expansion of diaparism and underplating, delamination occurs in some portion of the lower crust. Now I will explain about the geodynamic mechanism of basin formation and evolution. Geodynamic can be divided into three categories, which is lithospheric plate interaction, sublithospheric action, and earth surface action. Plate interaction mainly related to the extension, compression, and shearing. Generally, many normal and transtensional fault systems form in the continental rift during the process of passive lithospheric rifting. Oceanic crust form where the mid-ocean ridge emerge in the continental rift. Subduction of the oceanic plate or continental arc collision is formed when the extension occurs on one side of the continental block. Because of lithospheric shearing, both translational and compressional basin may be formed at different stages of lithospheric extension and compression. The next is sublithospheric action. This type of basin mainly can be found in China. It can be categorized as intensive late-stage reformation and active sublithospheric action. Sublithospheric action contains four main mechanisms, which is first is underplating, favoring the formation of metamorphic core complex, magmatism, related faulted, block, and continental rift basin. The second mechanism is diaphorism, mainly occurring during the subduction of an oceanic plate when the local convection and upwelling of mantle help to produce a back-up rift basin. The third one is a loading effect, occurring primarily in the collisional orogenic stage and resulting in crustal fracture as well as formation of orogenic belt and fallen basin. And lastly is the delamination, which occurring chiefly in the post-orogenic stage and favoring in the formation of rift basin. Other than that, the writer also lists out the four types of earth surface action which may form a basin mechanism. The first one is the gravity instability, atmospheric erosion, river and oceanic current, and biological action. Okay, now we move to the new geodynamic basin classification. It was actually the main focus in this paper. There is three types new geodynamic basin that had been identified by the writer. The first category is the prototype, the second one is the flexural, and the last one is the strike slip basin. Now we know about the prototype basin first. Prototype basin is the basin that formed under a single tectonic, thermal or gravity regime. Under prototype basin, there is five type of basin. The first one is the extensional basin. It formed during the first half of a Wilson cycle. The second one is the intracontinental extensional basin. It formed under an extension setting in a craton or continent where no oceanic crust formed. Intracontinental extensional basin include the intracontinental rift basin and aulacogens. The third one is the intercontinental extensional basin. This basin accompanied by the initial breakup of a continent and the formation of a new ocean crust. Next is the oceanic extensional basin. Oceanic basin growing with the spreading of the oceanic crust. The last type of basin under prototype basin is the arc-related extensional basin. This basin includes oceanic trench, fore-arc extensional basin, intra-arc extensional basin, and back-arc extensional basin. Okay, now the second type of new geodynamic basin is the flexural basin. This basin comprises of various basins formed under a compressional setting during the second half of a Wilson cycle. Under this basin, there is a few types of basin. The first one is the arc-related flexural basin. It forms in an active arc trench gap with its landward side connecting with the active magmatic arc and its oceanward side overlapping on the uplifted subduction complex. The second one is the peripheral flexural basin, a flexural basin forming on the continental crust of the subducting plate during the continent-continent collision. And then intracontinental flexural basin, a basin set forming in a continent by the contraction and buckling of the continental lithosphere. The fourth one is the Piedmont Depression Basin. This basin formed in the orogenic front after the uplift of the geosynclinal fault bed. And then the next one is the Piedmont Flexural Basin. This basin formed in the foreland of the cratonic margin adjacent to the default flank of an orogenic belt. And then the other type is the Intermontane Depression Basin, Intermediate Massive Basin, the Intermontane Compressional Basin, a backland basin, collision reef or an impactogen, a flank basin, and a collapse basin. The last category in the new geodynamic basin is the strike slip basin. This basin eventually formed by a strike slip faulting or escape and dominated by a transpression and transtension. It also includes the transtensional, transpressional, and transrotational basin. Under this type, there is a few type of basin. The first one is the transtensional basin. It means any basin formed by extension along strike slip fault system, including not only the classic pull-apart basin forming at releasing bands or step over along strike slip fault, but it also those forming where normal or oblique slip faults playing out from a large strike slip fault, then it's so-called transtensional fault termination basin. And the next one is the transpressional basin. This basin is formed in a compressional environment along strike slip fault system. The third one is the transrotational basin. This is the continued sharing of strike slip fault will the result in the rotation of the block between them around a new vertical axis. And the fourth one is the cratonic basin. This is a circular to ovate cluster site forming on a stable continental lithosphere at some distance from a continental margin. The next basin is the gravity exosestic basin, multi-stage superimposed basin, residual basin after the late stage formation, and the last one is the geomorphological basin. There is three conclusions that I would like to do in my presentation. The first one is the geodynamic mechanism, continental basin formation and evolution include lithospheric plate interaction, sublithospheric action, and earth surface action. Lithospheric plate interaction include plate scale extension, compression, and shearing. The next conclusion in the sublithospheric action include the effect of the atmosphere and mantle plume on the overlying lithosphere, especially cross-mantle interaction. The last conclusion is the geomorphological basin is a kind of basin or depression that does not have a close relationship with the sublithospheric action, but that form mainly because of its negative surface topography. And finally, there are two recommendations that I would like to highlight. The first one is the review paper presentation need to continue every semester since it will give more knowledge and more benefit to the student. And the last recommendation is a research paper should be provided in ULearn since students can have a more understanding about topic. I think that's all from me. Thank you.